In this math cast, we're given an angle alpha with a vertex A and a line with a point P. And we're to copy the angle alpha onto the line so that the vertex is P. So let's start by drawing ourselves an angle. We'll get our segment tool to draw an angle. Don't make it too big so you can stay in the space. So here's a first point and a second point, and go back to the first point, and let's make this one even shorter, that one. So this is going to be our angle here. If we were in real life, we'd draw an angle marker and write alpha. So how do we do that? In GeoGebra, we go to our decoration tool, mark off the 3 points. Now, GeoGebra will measure it for us, but we're not interested in that. So we right-click, go to Properties, and we don't want it to show the value, we want it to show the name. And so that it fits the name, we go to Style, and we make the size of the angle 50. There it is. Now we wanted this to be A. It is A, so just show the label. So we'll move it to over here. So here is our angle alpha with vertex A. Done with that part. Now we need a line. So we're going to put it over here so we have some space. We're going to put our 2 points this way. And remember, we need 2 points to determine the line, but we don't want to see this point, so we hide it. Don't delete it, just hide it. So I right-click and deselect Show Object. And we want this point to be called P. Right now it's D, so we go down to Rename, and we type in a capital P, Apply. And again, we want to move it off so that we can get our angle in there. So we have our angle and our line, and our idea is to copy this angle here so that the vertex is P. These 3 points determine a triangle, and what we want to do is draw that same triangle here, because triangles are magic things. If you know the lengths of the 3 sides, the angles are fixed. So we can find this length along this line. How do we do that? We use our compass. First, we measure the length of the interval by clicking on the start and the end point, and then into the center to get the circle. And so this intersection point right here marks this distance as this distance. So now what we want to do is find this point. We have these 2 points, but this point we're going to have to find this distance, and it will be the intersection. So we use our compass twice. First, we draw a circle with this segment length and center P. So let's do that. Click on the 3 points, start, finish, center. That gives us all the points that are this distance here. And then we draw a circle with center here and radius this distance. Radius, center, and there's our intersection point. So that we have actually copied this triangle here onto this triangle, and in doing so we copied the angle. So we get our ray tool and draw the upper leg of the angle. This angle is the same as this angle. So let's make our circles a little lighter, and then we'll come in and draw an angle decoration. Right click, Properties, these are all our circles, dotted, dotted, dotted. Let's see. Oh yeah, much easier to see. So now we're going to get our angle decoration tool, click it, and these 3 points. Right click, go down to Properties, and remember we like it to be a little wider, and we want it to show the name beta, not the. So these 2 angles are congruent. Now, if you like things to be fancy and you want to put a line here and a line here to show that these angles are the same, there is a way in GeoGebra. Right-click on the angle, go down to Properties, Decoration, and we will pick the one that says this one, and we'll do the same thing over here on Alpha, Alpha, Decoration, and pick the same decoration. And now we have our angles marked as congruent or the same size. Finally, we check that our construction is good by moving the angle endpoints That is changing the angle alpha and making sure that the angle beta changes the same way. So we'll pick this point and change it. There we go. Good. And this point. There we go. So our construction is good. We have copied our angle.